Hello students, good afternoon everyone. Hope you are getting my voice clearly. If there is, if you are not getting the voice or the screen clearly, please ping me in the chat box. Please ping me someone if anything is not proper. If you are not getting the voice clearly or screen is not displaying properly, just ping me once. Right. Alternating currents. So briefly, first 1 minute, let us try to recollect back the points which we have discussed already. Alternating currents. Right. In the previous sessions, we have discussed about what is alternating current and what is alternating voltage and how to represent mathematically alternating current and alternating voltage. So the current which changes with the time periodically is called alternating current. Mathematically it is expressed by using the relation I is equal to I naught sine omega t or I naught cos omega t also, or I naught sin omega t plus phi with some initial phase as well. So this can also be expressed as I naught sin omega t plus phi, where phi will be initial phase. That this term is called as total phase or phase angle. At time t equal to 0, this will be the phi will be the phase. That phase is called initial phase. Similarly, alternating voltage is represented as V is equal to V naught into sine omega t. Just a second, guys. I hope you are getting the voice clearly without any resound or some other voice issues. Right. So the alternating voltage similarly can be expressed as V equal to V naught sin omega t, or with some phase difference I equal to, sorry, V is equal to V naught sin omega t plus phi also. This phi can be 0 and this phi can be 90, whatever it is. We have discussed with different parameters, and we have discussed about in these expressions, in current expression I is equal to I naught sin omega t. This term is called peak value of alternating current, and here this V naught is called as peak value of alternating voltage, peak value or maximum value or amplitude. And we have also discussed about average value of current and average value of voltage over full cycle is equal to full cycle average value of current and average value of alternating voltage also, or full cycle voltage where in half cycle over half cycle is equal to yes 2 I naught. This is actually, you can write separately here, this is equal to 2 I naught by pi, and average value of voltage is 2 V naught by pi, etc. Similarly, RMS value, root mean square value of current, is given by I naught by root 2, where I naught is peak value, here also I naught is peak value. Similarly, uh, average value of V over half cycle and VRMS also we have discussed. So these points, of course, we have to keep in mind. And in addition to those, we have discussed about some other basic terminology, like what is impedance, what is impedance, Z, and what is phase and phase difference, phase difference, and how to express the alternating current and alternating voltage in waveforms, waveform representations. So these are important now, that's why this I am recollecting back all these points. Waveform representation, waveform representation, waveforms of alternating current and alternating voltage, and phasor diagram, phasor diagram. So how to draw phasor diagram also we have discussed. Phasor diagram of alternating current and alternating voltage, and how to understand the phase difference between them. Based on the phase difference, we can understand which is leading over the other, that is the alternating current or alternating voltage. Now the important, the actual concepts now we are going to discuss are pure resistive circuit, pure inductive circuit, and pure capacitive circuit. And in these circuits, how alternating current and alternating voltages are related by, and how they will be related with one another. So first one, let us see briefly, and then we will try to work out some numericals as well. First one, pure resistive circuit, pure resistive circuit, pure resistive circuit means, let us consider a circuit in which a resistor of resistance R is connected to an AC source. In current electricity chapter, we have dealt with the combinations of resistor and batteries. Like a resistor is connected to a battery of potential difference V volts, and then a current I will be drawn here. If it is resistance is R, and if I is passing through this, a potential will drop across this resistor, that is given by IR according to Ohm's law. V is equal to IR, potential drop across the resistor is IR. And this battery is called as a DC source. This is nothing but DC source, DC current source or DC voltage source or DC source. Actually, it is not DC current source, DC source you can call as. Actually, this will deliver the power, actually speaking, right? So this is a DC source. So here we consider AC source. We are discussing about alternating currents and alternating voltages. So we consider here this is AC source. AC sources will be represented by this symbol, this like this kind of symbol will be used to represent AC sources. Tilt. Okay, AC voltage source, let us say. So that the voltage, alternating voltage given by this source is V is equal to V naught into sine omega t, where omega is angular frequency and t is the time. When the current is drawn from the source, we call it as AC current. The I will be drawn from this, and when it is passing through this, the potential will drop across this. So that potential dropping across this is nothing but IR. IR. This I is nothing but instantaneous current, we can call it as. So IR will drop here. IR will drop here. So we can say that just like in the what do you call it, DC circuits. Here if you have a battery connected to a potential, the entire potential will drop across this, right? So V is equal to I into R. Similarly here, this V is equal to I into R. You can say that R, by applying Kirchhoff's laws, uh, what do you call it? The sum of algebraic sum of the potentials across all elements will be equal to 0. Or simply you can say here there is a V minus IR equal to 0, or directly we say V is equal to IR. Here V is alternating voltage. Here V is alternating voltage, and I is alternating current. So already we have discussed the mathematical expressions for those. Here V is nothing but V naught sin omega t, and I is equal to I naught sin omega t. So here you can rewrite this as already V is given. If you want the expression for I, we write it as I is equal to V by R. This is equal to, now let us substitute V expression here. V is equal to V naught sin omega t. So let us write it as V naught by R into sin omega t. Here, this V naught by R, let us replace with I naught. We call this as maximum value of current. I is equal to I naught sin omega t. As the AV, alternating voltage from the voltage source, if you take this as V is equal to V naught sin omega t is the first expression if we consider, and I is equal to I naught sin omega t if we consider this as second expression. From these two expressions we can understand that here the phase angle of voltage, alternating voltage, is omega t, and phase angle of alternating current is also omega t. The phase difference between them is 0. So we can say the alternating voltage and current are in phase, right? So for this, the waveform representation and hence a phasor representation can be given just like as shown in here. The waveform representation, if we consider time or the total angle omega t itself, omega t and I, or V, at time t equal to 0, if you observe here, V changes sinusoidally. This already we have discussed. So no need to just spend more time here. Just you can directly consider this. So this is I representation where, but in terms of time period we have discussed in the previous session. Now here in terms of omega t, if you consider omega t is 0 in terms of angle, you can say omega t is 0, pi by 2, pi. So this is pi by 2, 2 pi by 2 or pi. This will be 3 pi by 2. This will be 4 pi by 2 or 2 pi. For different angles we'll get this values. So this value of current, if we say this is current, so as current is 0 here, the maximum value of this will be expressed as I naught. If you take it as voltage, it will be V naught. But here we have to observe that V naught and I naught is nothing but, here you can write, because here I naught is equal to V naught by R, it will be less than V naught. So let us say if this is I naught curve, I, that is I equal to I naught sin omega t, then V, that is alternating voltage, can be represented with a wave whose peak value will be more than I naught. This is I naught, this will be V naught. Similarly, this is a negative peak minus I naught, so we will get negative V naught will be here. It can be represented like this, right? So that this already have discussed, this you can recollect back. And the phasor diagram for the same, can be understand in the different ways, guys. So one is with respect to this horizontal. If you say the angular position is omega t, then here both are in phase, which I have discussed, right? So if you say this is V naught, then I naught amplitude will be lesser, so the length of I naught can be taken as a smaller one. You can take I naught amplitude can be the smaller one. This can be I naught. Right. So the angular position will be theta, that is equal to omega. Both will have same. So or you can also represent this also as along the reference line only, reference line itself also you can express along x-axis. That is V naught and and I naught and I naught, with I naught magnitude is smaller than V naught, because the phase difference between them is 0. Along same line you can consider these two. So this is another way of representing the phasor diagram. Either this way you can represent or this way you can represent. In the questions, if you come across either of this way, you have to understand that both are correct only, but provided they both should be along same line with respect to the reference line, right? So now the next one is, so let just I am spending little again some more time here to understand here itself how to understand, how to deal with the questions part also. Right, next one. So note down the pure, this is pure resistive circuit. Next one is pure inductive circuit. So what are the points you have to keep in mind related to pure inductive circuit? In pure resistive circuit, how I and V are varying, and how to represent this waveforms and phasor diagrams for these corresponding diagrams. Now the second one is pure inductive circuit. Pure inductive circuit. Pure inductive circuit. So in pure inductive circuit, we will be having only inductor. Inductor is represented with symbol with inductance L. If this is connected to an AC source or AC voltage source or EMF source, so that the EMF given by this is V is equal to V naught sine omega t. Then AC current will be drawn from this. So, and this current when it is passing through it, through an inductor, in EMI chapter, previous chapter we have discussed that when current is passing through inductor, EMF induces, and EMF induced in an inductor is given by E is equal to, according to what you call Faraday's laws, E is equal to minus d phi by dt and hence here that is phi is a flux, change in flux with respect to time. This can be expressed as minus L into di by dt, that is EMF induced across the inductor. This we have studied in the previous chapter. You have to remember this, guys. Let's say this is one. And according to Kirchhoff's laws, vector sum or algebraic sum, algebraic sum of the potential drops across all elements in the circuit closed loop is equal to 0. And in this case, V, and this will be small e, V plus small e equal to 0 or V equal to small e, or you can say that this small e is nothing but minus dl by dt, or you can write V minus L into di by dt is equal to 0 from Kirchhoff's laws. From Kirchhoff's voltage law. Now this further you can write it as V is equal to L into di by dt. Here we have connected an inductor, pure inductor to an alternating voltage source. It is giving you an alternating EMF of V equal to V naught sin omega t. We know this one. So here now what you have to keep in mind is potential due to the alternating source is V is equal to V naught sin omega t. Let's say this is equation 1. And with the help of this, you have to understand when you are drawing the current from this source, what should be the current in terms of this EMF, in terms of alternating EMF. To understand this you have to rewrite. How to rewrite this is, if you send L here, you can write it as di by dt is equal to V by L. Di by dt, here you can write di by dt is equal to V by L, where V is V naught sin omega t. So V naught by L into sin omega t, and we want current. So it is di by dt. You can say it is a differentiation of current with respect to time. To get the current, you can rewrite this as di is equal to V naught by L into sin omega t dt dt. Or if you integrate it, this actually if you integrate on both sides, if you integrate this, we'll get integral of di is nothing but I is equal to V naught by L into integral of sin omega t dt is nothing but minus cos omega t, minus cos omega t by omega. So if we bring this omega, and here we will write it as I equal to minus V naught by omega L into cos omega t. This entire thing will take it as we'll take this as what, the maximum value or amplitude of this current. So we can write it as I naught. But this negative sign, if you bring it here inside, you can write it as the cos of minus omega t. This point you have to be careful, guys. Already I have taken so much time and I have explained you when to take what do you call it? Cos omega t. Cos theta can be expressed as sin 90 minus theta, sin 90 plus theta. Both can be expressed. But here, if you have negative sign, if you take negative sign inside, it will become cos of minus omega t. So that can be expressed as, we can write it as V naught by omega L is I naught into sin omega t minus 90 can take, or pi by 2, minus pi by 2. When you have a negative sign, minus pi by 2, better to take. If there is a positive, there is no negative sign, then you can take omega t plus. I hope you have understood this. There is no confusion, I hope. So because of this negative sign, we can write it as minus omega t. Cos of minus omega t can be written as, or simply say cos theta is 90, 90 minus theta. Here you can write cos theta is equal to sin 90 minus theta. But if this can also be written as sin of minus of theta minus pi by 2. So minus theta plus pi by 2. So pi by 2 minus theta. This you can write it as. So here, if you have just a sign cos, what do you call it? 90 minus theta is theta only. But if you want this theta to be negative, minus of minus theta you can take. Plus theta or minus of minus theta also you can take. So that gives you a negative sign here. So for that purpose, we are taking here this negative sign will bring inside and we will write in this way. But it will give you positive sign only, right? Now let us get back into this here, this comparison part. I is equal to I naught into sin omega t minus pi by 2 you can write. This also we have discussed briefly how to represent these expressions. Let me say this is equation 2. In case of pure inductive circuit, alternating voltage or potential is given by V equal to V naught sin omega t, whereas alternating current is given by I is equal to I naught sin omega t minus pi by 2. So because it is omega t minus pi by 2, we can say current lags behind the voltage. Current lags behind the voltage. So how to draw the waveforms, and hence what you call phasor diagram. So you can just briefly you can recollect back the concept of what is that waveform representation. This is I or V, and if this is instead of time period, if you take omega t total angle, it is when it is 0. So when is sin omega t is 0, sin 0, potential will be 0. Potential will be 0. So and hence it follows the sine form. So you can take this as a sine form. You have to take little larger value for peak value of this. right? So you can consider the sine waveform. So this is peak value of potential, and this is peak value of potential in the opposite direction, or negative peak potential maximum value. Whereas at time t equal to 0, we'll get minus sine minus pi by 2. So this becomes minus of sine pi by 2. Sine pi by 2 is 1, minus 1. So it will become minus I naught. Negative value here we'll get. So but I naught will be less than V naught. If it is somewhere here, then you can say that it starts from here, and at pi by 2, potential will become maximum, but this becomes 0, and here it will become potential becomes 0, but this becomes maximum somewhere here, and it varies accordingly. Here it becomes maximum. So that is here, minus I naught you have to consider. It becomes minus I naught. So this representation you have to understand little carefully. So this is minus I naught, this will be plus I naught. So I naught will be less than V naught. This is for pure inductive circuit, waveform for pure inductive circuits. And what you can understand here, current lags behind potential. Potential starts at 0, starts increasing from 0 value, but still it is in negative value. To come to 0 itself takes more time. So it is behind potential. Behind potential means it is lagging behind potential. That's what you can understand. So that's what you can conclude also. Just uh, conceptual based questions or theory based questions based on this waveforms also will come. You have to be understand this carefully. So draw this. So don't simply listen and leave it. Draw this, then only you can understand carefully. Draw this waveforms. Draw this waveforms. Next, the phasor diagram, phasor representation. Phasor diagram. Phasor diagram for the same. What is that? For pure inductive circuit, how to draw this is, if you consider the horizontal direction is the reference one, and if current, as it is here you have understand that current is lagging behind potential, and it is having positive value. Let us consider current value is this I naught, and the potential is like it is ahead of current by an angle of pi by 2 radians or 90 degrees. This is V naught, this is I naught. So this is how we can represent the phasor diagram for this. Whereas for pure resistive circuit, both are in same direction with the different magnitudes. Here, both are differentiated, both are separated by a phase difference of pi by 2. Here, phase difference. In this, we can understand this. This is the phase of potential, this is phase of current. So if this is phi 1, this is phi 2, you can say phase difference. Phase difference between alternating current and alternating voltage in pure inductive circuit is delta phi is equal to omega t minus, you can see here, phase of voltage minus phase of current. You can take pi by 2 the value. You can take if you take omega t minus half minus of omega t minus pi by 2 you can take. Otherwise phi 1 minus phi 2 or phi 2 minus phi 1 you can take. If you want only magnitude part, you can take omega t minus half omega t minus pi by 2, then we'll get minus omega t plus pi by 2, so we'll get pi by 2, that is 90 degrees. That is the phase difference. Phase difference between alternating current and alternating voltage in pure inductive circuit is 90 degrees, whereas in pure resistive circuit is 0. In pure resistive circuit, the phase difference is 0, and hence we can draw the what you call phasor diagrams like this. So from this you have to keep in mind that we have discussed about power representations, right? Those also you can represent here. But while doing the numericals, we'll try to recollect back. No need to just again discuss every theory points here. So next, let us see what is a pure capacitive circuit and how the alternating current and the alternating voltage will relate with this. Pure capacitive circuit. Pure capacitive circuit. Pure capacitive circuit means only capacitor is connected to AC source. AC source. So let us consider a capacitor. For a capacitor, both the lines will be parallel. Don't draw one bigger and one smaller. It becomes a battery. Okay. So this is a capacitor. So this is an AC source. AC source, EMF source. So its potential is given by V is equal to V naught sine omega t, as V is equal to V naught sine omega t is the power supply. If we take this as equation 1, and from this AC current is drawn. This actually he is speaking here, in case of capacitive circuit, we will not draw current from the source, but charge will flow. A few more additional points just you have to keep in mind when comparing all the circuits is, in inductive circuit, current will be drawn, alternating current will be drawn, and it will passes through the inductor, even in resistor also. But alternating current will passes, and it will while passing the alternating current, it experiences some opposition to it. But whereas in case of capacitive circuit, it is called as a DC blocking device. Capacitor is called, you can write it as this as a note. It is called as a DC blocking device. Means it will not allow DC blocking device. So even you have discussed about the capacitors connected to DC source called battery in current electricity chapter, but it allows AC, but it will not allow DC. When you connect this, the capacitor just started to charge. So charge on a plate start increasing gradually. You can say that accumulation of charge, and after getting the steady state, we can speak about charge of capacitor, the potential of capacitor, and the energy stored in the capacitor, etc. All those terms just here also can relate. Now we can say that capacitor is a DC blocking device. That means it allows AC only, and allows AC. So if you connect this to AC, so a charge will be drawn from this, and when charge is passing through the capacitor, potential will develop across this. That potential, if it, when it is like it is an alternating current, is alternating potential will develop across this. That potential is given by, from the definition of capacitance, you can say, because Q is equal to CV. From this you can write it as V is equal to Q by C. This small q or capital Q, anything you can take. Q by C will be the potential drop across the capacitor due to what? The flow of charge drawn, or the charge drawn from the AC source. And again, by applying what? Kirchhoff's laws. From Kirchhoff's laws, algebraic sum of the potentials in a closed loop equal to 0. The potential drop across this is nothing but, you can take it as a small v, or whatever it is. Small v, that is nothing but Q by C. So, or you can say this is equal to this. So this minus Q by C is equal to 0, because here if you say this positive negative potentials with the sign, if you take E minus Q by C is equal to 0, that gives the relation here, E is equal to Q by C. But from this you can write as Q is equal to E into C, or C into E, where what we have taken is E. So let us take it as V, not E. Different symbols you can take. Let us take this as V. V is equal to Q by C. So Q is equal to CV. C into V is alternating voltage or alternating EMF. So is equal to C into V naught into sine omega t. Now we can say as what we are trying to write, Q is equal to, this is Q. Q is equal to CV naught into sine omega t. So we want to know how the alternating voltage or alternating currents are varying, and how they are relating in a circuit. In capacitive circuit, resistive circuit, inductive circuit, capacitive circuit. Alternating potential is okay. How to get the alternating current from this? We know already I is equal to dq by dt. So where q is this? If you substitute this q here, you can write it as d by dt of q is cv naught into sine omega t. On simplifying this further, we will get Cv naught is a constant as we are differentiating with respect to time. Then we will get I is equal to Cv naught into differentiation of sine is cos. So cos omega t into omega will come here. So we bring this omega here and we write as omega c into v naught. But this entire thing can be called as amplitude of I or maximum value of I, that can be expressed as I naught. So I is equal to I naught cos omega t. So where I naught is equal to, you can further actually current from Ohm's law is equal to what? Potential by resistance. In this case, okay, in inductive circuit also we introduce one term, and now we will compare a term, the related term. If you observe here in inductive circuits, we have taken this as I naught, right? Here we will introduce few terms. That terms now altogether we will discuss once. So this can be taken expressed as I naught into cos omega t. So this, if you bring it here, is equal to I naught cos omega t is a cos plus omega t. So this can be expressed as I naught into sine omega t plus pi by 2. So this you can take it as equation 2. Here we can observe that the current is omega t plus pi by 2, means it is 90 degrees ahead of the potential. So we can say that in pure capacitive circuit, alternating current leads alternating voltage by pi by 2 radians or 90 degrees. Or you can say in pure capacitive circuit, alternating voltage lags behind the alternating current by pi by 2. This is leading means that lags. So accordingly, now only this we are discussing about how to represent waveforms and phasor diagrams. So after that we will discuss here few terms which are related with the opposition part. Opposition in the sense opposition for flow of charges or flow of currents in resistive circuits, capacitive circuits, inductive circuits. That is in this particular case, this part can be, here we introduce one term called reactance. What is that reactance in capacitive circuit? In inductive circuits, we'll see afterwards. So here, this for this, if you draw waveforms for I or B with respect to omega t, as this from according to equations 1 and 2. At omega t equal to 0, b equal to 0, and it varies sinusoidally. But here, at time t equal to 0, it is pi by 2, so I naught, but positive only, right? So how can you draw the waveform for this is, if at time t equal to 0, potential is 0 and it varies. Like this, if you consider the waveform, this will be the peak value of V naught, positive peak is negative peak if you consider. Whereas for current, at time t equal to 0, it is pi by 2, so at time t equal to 0 itself, current is not 0, current is I naught. Current is I naught. So that peak value, if we take it as I naught, and I naught always will be less than V naught. So from here onwards it changes. When the potential maximum, current will become 0. And when this is 0, it becomes maximum. You can say negative maximum of current is this. Then again, when this is negative maximum, this becomes 0. And when this is 0, it becomes positive maximum. So if you join these points, you will get a waveform like this. So this is the waveform of EMF and this is the waveform of current, alternating EMF and alternating currents. So here what you can understand here is alternating current, when at time t equal to 0, alternating EMF is 0 but alternating current is having some positive values, so that means it is ahead or it is leading. That's why I say alternating current leads the alternating voltage by pi by 2 radian in pure capacitive circuits. To represent the same in phasor diagram, let us try to look at the phasor diagram representation. Draw this once quickly, draw this everyone. So phasor diagram. So if you consider this is the reference line, and as current is leading, alternating current is leading behind what you call voltage. Usually current will be, if you take it as along the reference line, this is current, so that if its peak value is I naught, voltage should be taken as it is lagging. Voltage is lagging behind this, means you will take in this quadrant. So usually V naught will be more. Voltage will be larger, so you have to represent with what you call lengthy line, so they represent V naught. So and the phase difference between them is 90 degrees or pi by 2 radians. So this is how you can represent the phasor diagram or phasor representation of uh, alternating current and alternating voltages and their peak values in this form. Got it? So this is brief representation. Now let us go back and observe what is that resistive terms. The resistive term in pure resistor circuit, the resistance offered for the flow of current in resistor is nothing but R only. So here if you observe, V is equal to V naught sin omega t, I is equal to I naught. I naught is nothing but here V naught by R. I naught is V naught by R. So this is resistance. So according to Ohm's law, V by R is current from Ohm's law. From Ohm's law. From Ohm's law. Whereas in case of pure inductive circuit, if you observe, peak current or maximum current, here I naught, we have taken omega V naught by omega L is I naught we have taken directly, but we have not discussed anything about here. So here you have to add a point, that is where I naught is equal to V naught by omega L. From Ohm's law, current will be equal to potential by resistance or resistance term, related term. In AC circuit, especially pure inductive circuit, the resistance term will be taken as XL. We call it as inductive reactance. So V naught by XL will take. Here XL is called inductive reactance. Inductive reactance. So inductive reactance XL is equal to omega L, but omega is angular frequency. So while doing numericals, we have to based on the requirement, you can take XL equal to omega L or 2 pi FL also, depending on the data, given data. You have to use this terms and you have to calculate. If you are asked to calculate by giving this, if you give by giving frequency for and L, if you are asked to find this XL, you have to use this relation. You have to keep in mind this. Inductive reactance is given by omega L, this is equal to 2 pi FL. From this, you have to keep in mind that. Now let us bring these terms here. What do you call resistance or inductive reactance XL and capacitive reactance, you can take it as XC, resistance, inductive reactance, capacitive reactance XC. So resistance, usually the opposition you can take it as R, but the corresponding term in pure inductive circuit or analogous term is nothing but XL. So as the resistance is measured in ohm, XL also will be measured in terms of ohm only. It is nothing but the opposition kind of resistance, but it is equal to omega L. So this can be expressed as 2 pi FL. So whereas capacitive reactance, if you look into this equation here in capacitive circuit, omega C V naught is taken as I naught, right? Here, if you observe, I naught is equal to what? Omega C V naught. But usually from Ohm's law, current is nothing but potential by some resistance term. So here potential is V naught. To represent this by some resistance term, this will take here to denominator and we will write this as 1 by omega C. This will act as resistance term. 1 by omega C will act as resistance term, and this resistance term in capacitive circuit will be called as capacitive reactance. So this we will bring it here. Capacitive reactance is represented as XC. It is equal to 1 by omega C. If you observe here, this can be expressed as V naught by XC, where XC is called capacitive reactance. It is equal to 1 by omega C, right? So So this further can be expressed as xc is equal to 1 by 2 pi f into c. And few more observations you can point out based on these relations. That is, if, of course, it is in pure resistive circuit, resistance is this, and resistance as I is equal to V naught by I naught is equal to V naught by R. The resistance part is given by this R. Whereas here, in this case, I naught is equal to V naught by XL will get. Here, I naught is equal to V naught by XC will get. So now if you observe here, the reactance, inductive reactance depends on some terms. From this is directly proportional to inductance of the inductor, and it also depends on angular frequency or angular velocity. If angular velocity is given, and if you are asked to find how if it is varying, how it is varying, if you ask, you can say it is varying linearly with this. But in terms of linear frequency, if you ask, as it is equal to 2 pi f, you can also say xl is directly proportional to linear frequency, xl is directly proportional to inductance. So we can understand, or we can study the relation between inductive reactance and frequency and inductance with the help of graphs. So here, if you observe the graphical representation of XL and frequency, so they are directly proportional, means you will get linear relation. So if you say this is making an angle theta with the frequency axis, then if you take the slope of this graph gives the vertical change in vertical side by change in horizontal side. This is nothing but XL. Slope is equal to tan theta is equal to XL by F. These terms are used for this kind of graphs also. Directly concept based graphs will be asked in questions. You have to remember this. So what is the slope of inductive reactance and frequency gives? It is equal to XL by F, or you can say XL is nothing but omega L by F. Omega can be expressed as 2 pi F into L by F. So you'll get this gives you 2 pi L. So slope gives 2 pi L. So this kind of questions also will come. So you need to have an idea. Whereas in capacitive reactance, XC is inversely proportional to angular frequency and hence linear frequency also, and it is inversely proportional to capacitance. Inversely proportional to capacitance. So here you can say here the relation between XL and F is this. Same way XL and L relation also you can give. XL and XL and L relation also can be given the same way, because they are directly proportional. You will get a straight line. If it is making an angle theta, theta is not given directly. The change in parameters by vertical parameters by horizontal parameters gives slope. Otherwise, if theta is given, you can take slope is equal to tan of the theta. If the 30 degrees or 40 degrees or whatever it is, if the angle is given, you have to take this here. Otherwise, change in y coordinates means vertical coordinates by horizontal coordinates or x coordinates you have to take. So here in vertical axis we have xl. This is xl. So it is equal to xl by l we have here. Here xl by f, xl by l here. But xl is what? Omega l by l. L cancel, you get omega, or simply 2 pi f. Slope of xl l graph gives omega. It is nothing but what? Omega. Angular frequency. That is what you have to understand. Right? So direct conceptual based questions will come based on this. Next point, similarly, the graphical relation between C and F, XC and C can also be understood. Here, let me draw simple, small graphs to represent those. So if this is XC and this is frequency, as they're inversely proportional, inverse relation is given by this parabolic curve, inverse parabola. So whereas for XC and C curve, they are also inversely proportional. So this also will follows this relation. Okay, inverse relation. This follows straight line relation. This follows inverse relation. Right? This is a kind of 1 by x graph. 1 by x graph. These points you guys have to remember. This is XC versus F graph. This is XC versus C graph. Right? These are few simple points about pure resistive, capacitive and inductive circuits. Now let us see few numericals, then we'll let us see what you call LR circuits, CR circuits, etc. if time is available. So now let us see some numericals. Let us consider, let us open a level 1 exercise 1 or exercise 2 questions. Level 1, exercise 1 or exercise 2. Open your volumes. Open your volumes. So questions based on pure resistor, pure inductor and pure capacitor based questions. Level 1, exercise 2. Page number 157. Level 1, exercise 2. Exercise 1 questions you guys try. Exercise 2, let us see few questions. Page number 157. Right. So let us start with question number 12. Question number 12. So what is given here and what you are asked to find? So it is given that a 220 volt 50 hertz AC supply is connected across a resistor of 50 kilo ohm. The current at time t seconds, assuming that it is 0 t equal to 0 is. What is this? What is given and what we are asked to find? It is given that a 220 volt 50 hertz AC supply. So already I told you, if you want again you can write down, there is a note. When you have given the line voltage ratings, the line voltage is treated as RMS voltage. So here what is given is 220 volt 50 hertz AC supply is given, means the voltage rating of supply voltage. So in supply voltage, potential will be taken as, in supply voltage, in what do you call, in supply voltage, V will be taken as VRMS. In households also can be taken as. So here VRMS is given as a 220 volts. If 220 volt 50 hertz AC means it's 220 volt AC with the 50 hertz frequency. F is equal to 50 hertz. When it is connected across a resistor, that means if you have a pure resistive circuit, it is connected to AC source. V is R. V is equal to V naught sin omega t. This is VRMS and F is connected to a pure resistive circuit having resistance. R is equal to 50 kilo ohm. Kilo means 10 to the power 3 ohm. The current at a time t seconds is what? What should be current at a time t is equal to t seconds? So we know what is this alternating current. So alternating current I is equal to, we know that in case of pure resistive circuit I is equal to I naught into sin omega t. In terms of resistance, if you want this, you can write it as I is equal to, I naught can be written as, from Ohm's law, I is equal to V by R. Here V naught by R into sin omega t. Sin omega t. So in the options, if you observe, we are asked to find out the, what do you call, the equation of current in terms of t. So here you have to calculate this value. Here RMS value, voltage value is given, but peak value is not given. Then how to find this? We know that Vrms is equal to V naught by root 2. From this we have to say V naught is equal to root 2 times Vrms. So it is equal to here root 2 into RMS is how much? 220. So root 2 into 220 or 220 root 2 into 220 volts is V naught by R. R is given as 50 kilo ohm, 10 to 10 power 3. This if you substitute here, then we will get, if we say this is equation 1, I is equal to, yes, do it yourself and simplify. V naught is what? 220 root 2 or root 2 into 220 by R value is 50 kilo ohm, 50 into 10 to the power 3 into sin omega t. Oh, frequency is given. So here omega t you have to write it as 2 pi f form. As frequency is given, you have to write this as 2 pi f form. So 2 pi into f is 50 into t. So 50 into 2 is 100 pi t. So on simplifying this further, what will you get? 0, 0 cancel. This further if you simplify, what will you get? 22 by 5. 5 4's 20. 5 4's 20. 2 remains. So point again if it becomes 24.4. 10 power 3 here it goes numerator, it becomes 10 to the power minus 3, right? So 10 power minus 3, 4.4 root 2 into 10 to the power minus 3 sin 100 pi t is current. This is in amperes. But in the options, if you see, every option is in milliamps. If this is there, you can take it as, but based on options we have to simplify. Now how you have to simplify further? This 10 power minus 3 has moved here and it is mentioned as 4.4 root 2. So root 2 is mentioned here, root 2 is not mentioned. This value is substituted and simplified further. So root 2 is how much? 1.4. So if you write it as, if you simplify this, you get 4.4 into 1.4, 1.414 into sine 100 pi t milliamps. This entire thing will be in milliamps. So this value, simplify, I will get 6.2 approximately. It will be 6.2 sine 100 pi t milliamps will get. This is the value of current. This is the current, alternating current value. You can say that it is passing through the resistive circuit at any time t. You can say this is instantaneous time, instantaneous current. The next point, next question. I hope you have copied this. Next question. So the question is given as the resistance of 20 ohm is connected to a source of alternating current rated 110 volts 50 hertz. Then the time taken by the current to change from its maximum value to the RMS value. What does that mean? Maximum value to RMS value. What does that mean? So let us try to understand this. The resistance of 20 ohm R is equal to question number 13. Question number 13. A resistance of 20 ohm is connected to a source of alternating current. So you can draw pictorial representation also if you want. This is resistance of resistor of resistance, or it is connected to an AC source. AC source. Its the readings are given as 110 volt and 50 hertz, right? So 110 volt is the voltage rating, means that is nothing but RMS voltage. VRMS is equal to 110 volt and its frequency is given as 50 hertz. Then the time taken by, what is the time taken by current to change from its maximum value to RMS value? That is, for what is the time taken by the current, for the current to changes from maximum value means peak value to RMS value, IRMS. IRMS means in terms of peak value, IRMS is equal to I naught by root 2. The current I initially is equal to I naught. We can say this is I1 and I2 is this RMS. You can the other way simply can take it as we know, I is equal to I naught sine omega t. I naught sine omega t. Here R is given, so you have to write this in terms of resistance. So it is equal to what? I is equal to V by R. So V naught by R. But V naught is given, VRMS is given. So further you can write it as V naught is equal to what? VRMS is V naught by root 2. So it is root 2 VRMS by R. Oh, sine omega t, I missed here. So V naught by R sine omega t. Sine omega t. The sine omega t, because frequency is given, let us rewrite this as omega as 2 pi f t. This further can be expressed as V naught is not given, V RMS is given. So because, you can write here within bracket, because V RMS is equal to V naught by root 2. From this V naught equal to root 2 V RMS. So root 2 V RMS by R into sine 2 pi f into t. This is I. I is equal to root 2 VRMS by R. by R into sine 2 pi ft. So what we are asked to find? When I changes from maximum value to RMS value, means this value to this value, how much takes for the current to change from this value to this value is the question. So initially when time is t, so at some time t equal to but at some instant, so let us say at here at some instant it is maximum, then is changing from this to this. So that means when I becomes IRMS, when I becomes IRMS, that is I naught by root 2. IRMS means I naught by root 2, which is equal to root 2 times VRMS by R into sine 2 pi ft. So much time takes for the I to become this much is the question. So what you have to do here, I naught, okay, here just you can represent, you can keep this I naught as it is also here, no need of be bringing all these things, okay. So yes, and simplify this further as anyway, I naught is not given. What are you given? VRMS, frequency, etc. are given. Here is simply actually just for working out this in terms of VRMS and R. We have replaced all this. So simply can keep it this I naught only, and here as it is I naught by root 2. This entire thing you can keep it as I naught, right? I naught. So this I naught we have written this as V naught by R, and then this one. This is entire thing is I naught only. So let us take this as entire thing is I naught. This is I naught. So this entire thing gets cancelled, and then 2 pi ft is equal to sine inverse of 1 by root 2. 2 pi ft is equal to sine inverse of 1 by root 2. What is this? For what value of what? For what angle of sine? We get 1 by root 2. Pi by 4, 45 degrees, or pi by 4. Pi by 4. So pi gets cancelled. So you'll get t is equal to 1 by 4. 1 by 4 into 2f is here. So it is 1 by 2f is equal to 1 by 8f. You will get, but frequency is given. What is frequency? 50 hertz. So it is 1 by 8 into 50 hertz is 8 into 50. Check it out. 50 hertz only, right? So what is 8 into 50? So 50 into, you can write it as 2 into 2 into 2, or 4 into 2. So 100 into 4, 400, 1 by 400. So it is, you can write it as 1 by 4 into 10 power minus 2, but 1 by 4 is 0.25. 0.25 10 to the power minus 2. What is this? Seconds. After this seconds it will reduce to this much is the meaning of it. So is there any such option? 0.25 into 10 power minus 2, 2.5 into 10 power minus 3 is there. So 10 power minus 3, 10 power minus 2 options are there. 10 power minus 2 only one option is there. 2.5 into 10 power minus 2, that is not correct. So if you observe 10 power minus 3, if you want to express this in terms of 10 power minus 3, you have to move one decimal here. So 2.5 into 10 power minus 3 you have to write it. So therefore t is equal to 2.5 into 10 to the power minus 3 seconds. This is how you have to calculate this. So 2.5 into 10 power minus 3, option 1 is right. I hope it is clear for you guys. I hope it is clear for you guys. Here actually no need to convert this I naught into all these terms. Simply can cancel out. Right. Next question number 14. Question number 14. So what is given here? Quickly. Question number 14. So it is given that a condenser of capacity 1 picofarad, one condenser means capacitor, keep that in mind. Condenser and capacitor both mean same, okay? Condenser equal to capacitor. Okay, a condenser or capacitor, a condenser of capacity 1 picofarad means capacitance of the capacitor is 1 picofarad. PF means picofarad. Pico means 10 power minus 12. 1 into 10 to the power minus 12 farad. is connected to AC source. So a capacitive circuit we are dealing with now. It is connected to AC source, right? So it is connected to AC source of 220 volt and 50 hertz. So VRMS is equal to 220 volt and frequency F is equal to 50 hertz. Frequency F is equal to 50 hertz. Then the current flowing in the circuit will be, so what is given? Read the question once again. A condenser of capacity 1 picofarad is connected to AC source of 220 volt and 50 hertz frequency. The current flowing in the circuit is how much? That means what is the alternating current? I. What is the current flowing in the circuit? Current flowing in the circuit, what is it corresponding to this can be called as IRMS, RMS current. So you can say as the current corresponding to this is nothing but, if you have to observe this, if it is like given in terms of what you call instantaneous current form, equation is given, then you should have written that corresponding equation. Here you can write it as I in terms of RMS voltage. You know from Ohm's law, I is equal to V by R. I is equal to V by R. But here, in case of capacitive circuit, RMS corresponding to VRMS, RMS current is equal to VRMS by the resistance term of capacitive circuit is nothing but capacitive reactance. Capacitive reactance. These points just you have to understand based on the conceptual discussion and you have to follow. So VRMS is given. What about XC? What about XC? Let us say this is equation 1. Here calculate this aside by the side where XC is equal to, XC is capacitive reactance, it is equal to what? 1 by omega C. Inductive reactance is XL is equal to omega L, but XC is equal to 1 by omega C. It is equal to 1 by omega is 2 pi F into C. F is given, C is given. So by substituting this, find out XC is equal to 1 by 2 pi F is how much? Or let us bring this here in place of this. So what will you get? It is equal to VRMS by 1 by 2 pi FC. So in this denominator of this denominator goes numerator, right? So further you can write it as VRMS into 2 pi FC. 2 pi FC. So this further gives us VRMS is how much? 220 volts into 2 into pi is 3.14. Again observe the options. If the options are in terms of pi, don't substitute pi value, otherwise substitute it. So question number 14, right? So they are not given in terms of pi, so substitute the value. 3.14 into F is how much? 50 and C capacitance is 1 into 10 to the power minus 12, 1 picofarad, 10 power minus 12. Simplify this. If you simplify this, you will get approximately 6.9 into 10 to the power minus 8. What you are finding? RMS. IRMS is equal to 6.9 into 10 to the power minus 8. So I am simplifying all this. So 50 into 2 becomes 100. And by simplifying with all the other zeros, you will get 6.9 into 10 to the power minus 8 ampere. This will be the, when you connect to this RMS potential voltage, you will get an RMS current of this much. Yes, I hope you guys have got it. Next, let us see question number 15. Question number 15. So let us see what is given here and what you are asked to find. What is given and what you are asked to find. It is given that in a circuit the frequency is, in a circuit here in this answer it is don't confuse, don't overwrite, especially it is 6.9 watts. Yeah. Right. Let us go ahead with 15th question. It is given that in a circuit the frequency is F is equal to 1000 by 2 pi hertz, 1000 by 2 pi hertz, and the inductance L is 2 Henry, 2 Henry. Then reactance will be, reactance of a circuit involving inductance is what? What is that inductance is called? Inductive reactance. Reactance is what is the question? So is a direct simple question, question, right? So what do you get? You know, inductive reactance XL is equal to omega L, but here omega is not given, frequency is given, so you can write it as omega as 2 pi f into L. Here f is given and L is given, direct substitute and find out. So it is equal to 2 into, again options are given in terms of pi or in terms of numerical values. So substitute all. 2 into pi 3.14 into f is, oh wait, f is given as 1000 by 2 pi. Don't substitute the value of pi, that's why this to have to observe while dealing with. This is not selected yet. Yep. For simplified calculations, as f is given in terms of 1000 by 2 pi, don't substitute pi, keep it pi as it is. 2 pi into f is 1000 by 2 pi into L is 2 Henry. 2. Here 2 pi gets cancelled. So simple. 1000 into 2 is your XL. So that implies XL, that is inductive reactance, is equal to what? 2000. What is the unit for reactance? Reactance is analogous to resistance. So ohm only. So ohm only. 2000 ohm. Or you can write it as 2E2 kilo ohm also. So depending on the options, you have to simplify this further. Ohms or kilo ohms or whatever it is. That's it. So right. So this is briefly about pure resistive, inductive and capacitive circuits. Next we'll see the combination of the elements like capacitor, inductor, capacitor, resistor, etc. That is LR series circuits and CR series circuit, LC series circuits and LCR series circuits. So this part we'll see in the next session, the combination of LRCR and LC and LCR circuits. Okay, so here based on this itself, what you call, based on the pure inductive capacitive circuits itself, try to work out with a few more questions given in other exercises. Let us work out at least one question from level 1 exercise 1 as well. Level 1 exercise 1. So here you see question numbers. What is time? 7:28. Oh, almost 7:30. Okay guys, then almost it is already 7:30 is dinner time, so I am stopping the session now. Then you guys can try yourself the questions based on this in other sections. Okay then, take care everyone, bye bye. We'll meet in the next session.